there isn't one magic bullet, one magic chemical that does all things. It's more often than not a mixture of different things.
What if one conversation could save a life? What if one new process or new product could save a patient from surgical harm? Broadcasting from a hospital basement near you, you are listening to the Beyond Clean podcast, the global voice of sterile processing. Each week we spotlight the best practices, products and people from around the world who are disrupting our profession and helping you fight dirty. Every instrument, every time. Join us as we have the kinds of conversation that matter and give our industry the kind of voice that it deserves. Nyt on aika mennä puhdastakin puhtaammaksi. And now it's time to go beyond clean.
This week on Beyond Clean, we speak with Chris Murphy, Director of Chemistry at Cantel Medical, and we're going to be talking about Endoscope, bedside cleaning. And Hank, this is a topic that is somewhat synonymous with point of use cleaning, and you hear about that a lot in industry guidelines and recommended practices. But today we're going to talk to Chris about the chemistries that are used in that process and what's happening microbially speaking in relation to, all of the bioburden and debris that can get caught up in the channels of these scopes when you're reprocessing them.
I thought on a season themed around chemicals, Justin, that it was important to talk to somebody who's got kind of the nerdy scientific point of view. No offense, Chris. But I thought it was important to bring somebody in there who's involved in putting these things together. Not just how they're used, not just the regulatory side, not just the cost side, but really that design side of chemicals. And I'm really looking forward to delving into that kind of science side of it, but then how all of that flows out into the implications about how they're used, the safety concerns, the future of these chemicals in our industry. Yeah, without further ado, I think it's almost time to bring Chris in to start this conversation.
Well, it's always a fun interview with Chris. You're going to enjoy yourself and learn a lot today. We're going to be right back after a short break with Chris Murphy, Director of Chemistry at Cantel Medical. I'm Justin Poulin.
And I'm Hank Balch.
From 17 Studios, you're listening to Beyond Clean, the global voice of sterile processing.
Joining us now is Chris Murphy, Director of Chemistry at Cantel Medical, now part of the STERIS family. And Chris, we've had you on the show before, and I'd say it was one of the most entertaining episodes that we've ever had. So now that I've set that bar, you got to go ahead and try to jump right over that like the pole vault. Chris, thanks so much for coming on the show.
So I'm a tall guy, so I'll try to do my best with that leap here.
As long as you get a running start, I think you'll be all right. All right, so we're going to be talking about bedside cleaning and specifically around endoscopes. And, obviously with the operating room, that terminology is point of use cleaning, but it really means a similar thing. It's just very different what we're going to be talking about today in terms of bedside cleaning. Is a little bit more of that GI, kind of terminology and really specific to endoscopes in particular. So just to kind of lay that out there, anytime you leave debris on any kind of an instrument, it's a risk to infection and or bioburden. That's another fun one, debris, bioburden. So Chris, why don't you give everybody a little bit of a background as the Director of Chemistry for Cantel? What do you do? And then maybe also tell us something you do for fun outside of work.
So my job as director is to run the sustaining projects, the new product development projects, and just the research in general that Cantel, now STERIS, does in our endoscopy division, effectively. So for those of you that work in endoscopy departments, the Medivator, the Advantage Plus, Advantage Pass-Through systems, many of these other systems, the DSD systems, 201 edges, those things, that's the chemistries, that's the research that my department is responsible for sustaining and developing and pushing forward into the future.
All right. And so what do you do for fun when you're not playing with chemicals?
I got a 3D printer behind me right here. So I got a project going on right over here on my workbench. And then I'm really avid outdoors. So like I kick my kids out and we go sledding all the time. During November, September timeframes, you'll find me up north hunting, trying to find something to eat in the woods, basically. So fishing is a big thing in the summer. Just anything I can do outside, any excuse I can get to get outdoors is my passion. That's
really the yin to that laboratory yang, right? That's so critical to have balance.
Yeah. all day in a fluorescent laboratory is no fun. And like, you just got to get out and get your vitamin D.
All right. So why don't we talk about bedside cleaning? Tell everybody what it is, but also tell us what is it not?
I learned about bedside cleaning when I first came into this job about 5 years ago. And it has like truly fascinated me since I've been in it. It is literally the most important step of the endoscopy process. Like it's thou shalt not bedside clean. Like you just like it has to be done 100% of the time. But there's really no like claims we can put around it. So, but it is the most important part, but yet we can't claim that it's the most important, but you have to do it. Otherwise the downstream steps won't work. It's baffling. It's intriguing. And like, it is like the most important step in the endoscope reprocessing chain.
So when you say there's no claim, Chris, or you can't put a claim around it like that sounds like a pretty technical term. What do you mean by that?
Yeah. So I can't claim that this is going to clean your endoscope because clean has a definition, right? I can't claim that it's going to kill the microbes to a certain level on that because that likely won't happen because of the use case. And it's a very manual process, right? So like manual intervention at that level won't get you there. Fundamentally, what it does is it keeps the soil, the detritus, the poop, for lack of a better term, from adhering to the endoscope. So it keeps it wet. It keeps it moist. It keeps the scope able to be processed in the downstream steps while you move it from the patient operating room to the reprocessing suites. And if you don't do it, your downstream steps won't work because the soil has time to gel and adhere and cling on to the insides of the endoscope. But when I was saying like claims around it, it's define wetness, right? Define like what do I mean when I say it keeps the scope moist? Like, how do I measure that, right? Like, so it does do those things, but like putting a claim on it to measure it is exceedingly difficult.
So you use three of my favorite words there: moist, detritus, and Klingon.
Yep.
But not necessarily in the context that I typically use it. But that point about defining clean, really caught my attention, obviously, because our company is called Beyond Clean. And so there is an assumed definition that we're going beyond something. And then this challenge, to your point, is so unique because you can't quite put your arms around what it is that should be happening to say, am I designing chemicals to make that thing that I can't define to actually happen? So knowing that kind of gray area, let's talk about chemicals in that step. Can you kind of talk about how you approach chemicals, what chemicals are involved in that process?
The basics behind it are that you want what are called wetting agents or surfactants or penetrating agents, basically chemicals that reduce the surface tension of water. Soap is a good example, like just a generic example of that. Reduce the surface tension of water and leave behind something that will start penetrating into the soil, loosening up the soil matrix, lifting it off of the surfaces of the PTF tubes or the stainless steel on the inside of it. So it comes down to just fundamentally just wetting agents in general. And those are huge. That's a huge class of chemicals. And we do research in our laboratories to determine what classifications or what types of wetting agents, what types of surfactants work best on the given soils.
Is it always a cocktail? Like, is there any just like one type of thing that you're like, this is the magic thing, and we're just going to use this one thing, or is it always a mixture?
If there was a magic bullet that like everyone would know about it, right? And that would be the one thing that everyone used. No, it's a cocktail. It's a cocktail of wetting agents and surfactants because in general, one wetting agent does one thing very well and another thing might do another thing very well. And so you mix them together to get the best of both worlds. So like you might have a surfactant or a wetting agent that really does well on proteins, but not so well on lipids and fats and things like that. And so then you add in another wetting agent that does well on lipids and fats to complement the protein one. And then likewise for blood, likewise for like hemoglobin. Additionally, there's no chemicals that I hate, things like simethicone that you want to add in. Different wetting agents to tackle those types of things because those are not natural human soils, but they are soils. So yeah, there isn't one magic bullet, one magic chemical that does all things. It's more often than not a mixture of different things.
So you mentioned sticky and Klingons, and I'm assuming that you're referencing biofilm when you're talking about that, but maybe you can clarify. And then also when it comes to what's in the cocktail that helps us attack biofilms, is there one specific agent that attacks biofilms, or does the cocktail itself address different types of biofilms?
So the biofilms themselves would be addressed in this manner. That's going to take some more intervention. Like a biofilm is a really hardy structure, right? It takes a lot of intervention, a lot of chemical force to penetrate through those biofilms. So if you have a biofilm in your endoscope, don't count on a bedside flush to help you get rid of it. That's for the downstream processes. That is for your sink side cleaning, your interventions, your brushing, your scrubbing. That's for inside the automated endoscope reprocessor. The different chemicals that are used in there are much more harsh because they're inside of a machine, so a person isn't interacting with them. And then we also have the sterilants and the disinfectants and things like that really attack the molecular structure, the microbial structure of those biofilms to get rid of them. Ideally, you should have a clean scope going into a procedure without biofilm or anything like that is permanently adhered to the endoscope. After you use it on the patient, you're going to have bulk soil, gross soil on it. So like mucus, feces, you name it. And the wetting agents in the bedside kit are designed to prevent that gross bulk film from adhering to the insides and outsides of the endoscope and prevent a biofilm from forming on there in the long term.
That's what I was looking for. Nicely done.
Yep.
So, Chris, we've talked a lot about what those chemicals are supposed to do proactively or in a good way to break down all of the bad things that you've been discussing. But what's the negative impact to the chemicals themselves in the process? Or what are you concerned about, I guess, in looking at the chemicals and designing these chemicals to be careful that you don't have reaction that you weren't planning on with the device?
Yep. People have to interact with these chemicals. So it's an actual person interacting with these things. So we want to maintain neutral pH. We want to maintain like some sort of biocompatibility measure through, there's a variety of different standards we can do that. But we want to be cognizant at this step that a person could get this on their skin, on a glove, on something like that. So we can't like dump 5% paracetic acid in this thing and expect, a person to interact with it. So it has to feather this line of removing the soils, wetting the soils, and being safe for people to be around. It can't give off harmful vapors. It can't give off toxic like byproducts or anything like that. It has to be benign, pretty safe.
Is there a push? This is kind of broader question. I'm just kind of curious since you mentioned some of those things. Do you feel a push or pressure in your corner of the industry, kind of in your role across the industry, to be moving toward more sustainable chemicals or more eco-friendly chemicals?
Oh, yeah. So one of my sustaining projects through the Cantel fiscal year this year was to get biodegradability and other testing done on the suite of our chemistries. And as we formulate going into the future, that is on all of our product requirements. It has to be environmentally friendly. Like sourcing from environmentally friendly suppliers and sourcing from environmentally friendly chemical lists, EPA safer choice lists, things like that. That's always on the front list. Now, in some cases, that's not practical. So you have to use chemicals that are derived from fossil fuels or derived from like carbon sources, things like that. But we try to make sure that those chemicals, as they end up in the environment, biodegrade into, harmless chemistries or harmless final products.
This next question I have is kind of softball maybe, but hopefully you can do something creative with it. Are all bedside chemicals created equal?
No. So they come in basically two different flavors, just on a broad category. You have enzymatics and non-enzymatics. In the end, they all kind of do the same thing. Wetting, breaking down the proteins, the different substrates to prevent it from adhering. We do test our competitors' products in the laboratory, and we have found enzymatic bedside kits that don't have enzyme activity in them. So
the claim is that they're an enzymatic, but the enzymatic action is not actually happening. So they could have enzymes in there. They're just ineffective enzymes. Can I ask you a question too? You said there's non-enzymatic and enzymatic. Is there a downside to enzymatic? I understand there's a downside to saying something does something when it doesn't, but is there a downside to an enzymatic on any level?
So there are certain jurisdictions around the world where they caution against the use of enzymes because in some instances they can be sensitizers. That is not the case in broad categorically, but in some instances. Enzymes are really good when you have controlled temperatures and controlled times and things like that. If you have a cold hospital, your enzyme activity is going to be lower than you would have a warm hospital. So an enzyme is just a means to drive a chemical reaction. And a chemical reaction's rate is dependent on the temperature in which that chemical reaction is happening. Enzymatics are fantastic chemistries. We use them all the time to clean endoscopes. They really, really drive the cleanliness of these endoscopes to a different level. With that said, is it necessary to use them at this juncture? Probably not. Does it help? Probably. But again, that goes back to that claim, like, I can't claim a level of clean at this step. What I can claim is that this step is preventing adherence to allow the downstream steps to do their
Sounds
job.
like a lot of lawyer speak, but I get it.
It is.
It is a lot of lawyer speak. And so you just talked about two kind of scenarios, right? If the temperature's not right, the enzymatic won't necessarily activate or activate as well as it could. And then you have another scenario where you might be buying a product where under tests, there really is no enzymatic, effectiveness. So if you're using an enzymatic and either of those is true, is it entirely ineffective in the process versus just saying, hey, we should have gone with a non-enzymatic and then we're covered? Or does it effectively work the same as a non-enzymatic if the enzyme action isn't happening?
At the end of the day, so the enzymatics as well have some sort of surfactant package in them to wet out the scopes, prevent adherence and things like that. The enzyme is just icing on the cake, for lack of a better term, to start that process of chewing up all of the proteins, all of the fats, all of the lipids, and just help with the cleaning as you go along. What level that occurs to is it significant? Probably, but again, it's hard. It's really, really hard to quantify what is actually happening at this step. I know if you don't do it, you're going to end up with some really poor outcomes downstream. But at this particular step, it's hard to quantify what's going on.
So let's say I bought one of these enzymatic detergents that you found in the lab doesn't actually have enzymatic action, how the heck would I even know?
That's a good question. You would have to test it using some sort of universal assay, or I don't know if they have test strips or meters for testing enzyme activity, but the way that we do it in the laboratories, we have universal enzyme activity assays. They're pretty laborious and labor intensive to do that work. And so like at a customer level, as a GI suite or a central sterile suite, I don't see you having a fume hood and a chemistry kit to do all of this testing here.
Well, that stinks. I mean, not the hood thing and everything. Nobody needs to carve out more space in their SPD, but I just mean to verify claims like that. You know, we hear all the time, like this product, you know, got validated. Now that it's in the facility, we have to verify that our process gets the same result, right? And you would almost want that same thing to be able to happen when it comes to the chemicals that you're using in the department, but it doesn't sound like that's quite as achievable.
I would say the most important thing that you can do is buy from reputable vendors, people that have histories in the market of delivering quality products and competing with other quality companies for space in these areas. So not to plug my own company, but like the STERIS enzymatics and non-enzymatics that we sell, our Cantel legacy products, I know that those work in the laboratory. They work very well in the laboratory. And STERIS and Cantel competed against each other for, gosh, I don't even know, decades in the market space. And we went back and forth, like with our marketing teams, went back and forth on those. We have really quality products that I know that do work, whether it's enzymatic or non-enzymatic for your use case.
So, Chris, you kind of lit a bomb there earlier with the test case and the non-enzymatic activity that we've come back to a couple of times. But I'm going to set up another explosion maybe for you here. Is there something to be said for how these chemicals are delivered? I know we're seeing in this space a lot of different delivery mechanisms on the point of use cleaning. And again, I understand that this is kind of two different conversations, but we're seeing foam, gel, spray, liquid application. Do those matter, or is it another one of these like such a gray area? As long as it's doing something, then it's good.
So the foams and like the whole purpose is to keep the scope wet. The whole purpose is to prevent the detritus from drying and building up on the scope. Because if you dry soil on a scope, it's a nightmare to get it off. Whether it's a gel, where there's a foam, that's the whole purpose. In the end, the bedside flush with liquid up the lumens, wipe down on the outside, will get you to where you need to go. The gels and the foams, in my experience, are meant to prolong that golden hour time frame a little bit, because the gels, they really don't dry out. The foams as well, they really don't dry out. But most IFUs don't let you violate that golden hour. AMI standards as well, they don't let you. They're really, don't be doing that. In the end, the important thing is just to keep the scope moist, keep the scope wet, so you can transport it from point A to point B, to get it in a sink, to get intervention, or get it into an AER with a cleaning claim, to get the actual cleaning process completed.
Before we go into the future of bedside cleaning and chemicals, I've just got kind of a practical question from the clinical back into the research side of things. So what's the most common misconception that you run into or question, kind of from the field that folks are calling in related to chemicals, that if you had an opportunity like you do right now to kind of set the record straight or do a little bit of mini education, like what would you like to just clarify once and for all for everybody?
Specifically just chemicals in general, or
chemicals in general is fine. Yeah, because this is a chemical season broadly, or you can speak to anything in particular.
Yeah. I would say the most important thing that you could do is read your SDSs and know what you're dealing with, because like the broad world of chemicals like runs from peracetic acid, part Rapicide PA Part A, which is really, really hazardous stuff if you spill it just natively, to bedside cleaning chemicals and detergents that we sell that I'm pretty sure that you could drink. Just
if you only knew.
What? We've already told that story.
Right. I'm like,
do you know this story?
No, I don't.
We seriously already.
Oh, okay.
Wait, hold on. So just tell me about the drinking part, because
no,
we've already told the story about this. That was kind of a rumor mill through the grapevine kind of experience for me from 10 years ago. But
please tell me there's a sales guy drinking detergents.
That was the story.
Oh, fantastic.
And it sounds like he got that from the Chris Murphy School of Chemical Safety.
Don't drink the chemicals.
Set the record straight there. Okay,
just do not.
You're just saying it's possibly safe enough. I'm just kidding.
Right. I mean, like, it's not going to kill you, but like you might want to die as it works.
We're just going to put a warning label on this episode to say, do not try this at home. Okay. That's the takeaway.
Do not try this at home. I mean, my point is, like, the hazard classes are on two opposite ends of the spectrum. Like, that's where we're at. So the most important thing you can do is, like, read your SDSs, right? Know what you're playing with. If you have hazardous things in your repertoire, aldehydes, phenols, things like that are on a pretty dangerous classification, work to get them out of your system. Because there's alternatives, there's replacements, there's less hazardous chemicals. At the end of the day, though, chemical hazard is a necessity because we are killing things, and you need dangerous chemicals to have the antimicrobial efficacy that you need to make these devices safe for patient use.
All right. So I'm almost scared to ask, but what is the future? What is the future of bedside cleaning? And, where can we take the development of chemicals to make this an even more effective process?
We can take the development to the point where we can start making claims on like soil reductions, microbial efficacy, generally working towards universal sterilization of these devices through the process, or not even to sterilization, but a very, very high bar of safety and efficacy for the customers and patients that use these devices. So if we can add in safe antimicrobial agents, different wetting agents to remove soils, enzymes to start chewing these different soils up, or things to remove simethicone, don't use simethicone, but things to remove the artificial soils that get introduced into these devices through regular use. It's going to be moving towards an end where we clean them to perfection and we disinfect them to perfection to make sure that the patients using these reusable devices are really safe and not harmed by anything.
All right, Chris, great job as always. And I think at the very end there, you did the pole vault over the bar that we set for entertaining episodes. So it was a pleasure having you on once again.
I really appreciate these. I hope I get to do many, many more of these into the future.
Just get into training for your pole vaulting skills, because we're gonna keep trying to bring it to another level. All right, everybody. That was Chris Murphy, Director of Chemistry at Cantel Medical, which is now part of the STERIS family. We talked about bedside cleaning, Hank, and I think the thing that really stuck out to me, and there's quite a few takeaways in this, and Chris is always entertaining, but the thing that really stuck out to me was the fact that, if there are claims about the efficacy, of like an enzymatic, there's really no way to, at the department, level, really be able to verify that those claims are actually happening, in your department. And typically you're going to look at that temperature, which is a real key point that Chris made, is ensuring that temperature for enzymatic activity is going to be in the right zone. I feel like that's something that you can sort of take a look at, but that's your own processes. It's not really verifying any kind of manufacturing processes. So it was a very interesting interview that way. I hadn't really thought about what's happening all in the background, especially as they these companies evaluate each other's products. That was another thing. I knew they were evaluating and developing their own, but the fact that they're kind of got their hands, in everybody else's cocktails, so to speak, and evaluating how the competitors are doing is pretty interesting.
Yeah, that piece about the product efficacy kind of blended over into a topic that I'm always very curious around, and it's that crossover between education and marketing, because we didn't talk about it, but each of these products are marketed in a certain way, and that's part of the claims, but you can actually do a lot of marketing without coming out and claiming something specific. It's interesting what that clinician hears when they see certain chemicals, or they hear certain key phrases like moisture or like clean, for instance, is one of those words that we brought up on this interview. So I am curious to hear more and actually to pay a little more attention now to the language that I'm seeing in these IFUs and in these marketing slicks around bedside cleaning in particular. So I thought it was a fantastic interview as well.
All right. Well, that's going to do it for this week's show. But as a reminder, you can help support Beyond Clean by subscribing on Apple, Amazon, Google Podcasts. You can also find us on Stitcher, iHeartRadio, Spotify, or your favorite podcast application. We've also got bonus content, but you got to download our smartphone app for iPhone and Android. And while you're there, we'd certainly appreciate a rating and a review, because your feedback is important to the show. And if you have any topics that you'd like us to cover on a future episode, just send an email to info@beyondclean.net. On behalf of Hank and myself, thank you for listening to this week's episode of Beyond Clean.